All right, question 43. A cylindrical can with closed bottom and closed top is to be constructed to have a volume of 1 gallon, approximately 231 cubic inches. So let me draw a beautiful can. Okay, and we have 1 gallon, so volume is 231 cubic inches. The material used to make the bottom and the top cost 8 cents per square inch, and the material used to make the curved surface cost 5 cents per square inch. Find the radius and height of the can to minimize the total cost, and determine the minimum cost, what that minimum cost is. Okay, so what you would do is to again create an equation. In this case, we would say this is I will use capital C for cost, and let's just say I'm going to use R for radius. Okay, so this can, we have a radius R and the height H. Okay, now what's the cost? We have the cost of the top and bottom, and also the cost of the side. So in terms of money, we have 8 cents per square inch, and then we have 5 cents per square inch. That's per square inch. You need to find out how many square inches of the bottom and top. You need to find out the total amount of square inches for the sides. So we will have pi r squared for a top, but since we have a bottom as well, so we have to multiply that by 2. Again, the meaning drives your work. Okay, there's nothing to memorize other than the fact that you should know pi r squared as the area of a circle. And the side of the container, the can, it's it's 2 pi r times h, because if you cut the side out, it's basically a rectangle. The length of the rectangle is 2 pi r, the circumference of it. And that's why we say we see the h right there, there's an r right there, and it's a lot easier to replace the h than to replace the r, since we have 2 places with r and only 1 h there. So that's why we have the volume given, because volume is pi r squared times h, and that's 231 cubic inches. So h is simply 231 over pi r squared. So we will replace it. Okay, so 0.08 times 2 pi r squared plus 0.05 times 2 pi r times 231 pi r squared. So for this one, it will be a calculated question, since there's no easy way to graph this. So once you plot this cost function, you will find out that it is again a rational equation, a rational function that will give you some sort of minimum in the first quadrant. Okay, and then this is the cost based on the radius. So you find out what the radius is, you find out what the cost is right there. And once you know the radius, you can find out what the height is. So the remaining is just a bunch of calculator manipulation. Okay, interpreting the values.